Hello everyone. In the last lecture we covered some of the basics and theory of discrete choice modeling. In the first part of the last week lecture we covered some of the topics related to the key elements in discrete choice modeling, utility maximization theory, deterministic and probabilistic utility functions, and characteristics of the error term in the utility function. We also discussed how to calculate probabilities of an alternative being selected among a set of alternatives using the multinomial logit model framework. In the second part of the last week lecture, we focused more on some activities related to the theory of choice modeling. We went over three activities covering a few important properties in multinomial logit models, and we discussed how to actually estimate parameters in a utility function using log likelihood maximization approach. In this lecture, I will cover a brief tutorial on how to estimate a multinomial logit model using an open source software called BIOGEME. I have uploaded a guide to BIOGEME on Moodle, as you can see here, to help you get started. The guide includes some instructions on how to install the softwares, what required materials you need to download, and gives you some activities and examples on getting you started on estimating your first choice model. In this lecture, we also cover two activities, one estimating a multinomial logit model and a binary logit model. So let's get started with downloading this guide to BIOGEME. This is a step-by-step guide which I would like you to follow to download the files, install the softwares, and go over some of the examples and activities as we will cover. So in the first step, I have provided you with a link to the software. If you go to the provided link, you'll see multiple versions of the software being available. I would like to start with the early version of the software, version 1.8, which can be installed on both a Mac or a Windows operating system. Depending on your machine, go ahead and download the zip file that is appropriate for your operating system. I have a Mac, so I'm going to download this BIOGEME V18 Mac OSX.zip. If you have a Windows machine, you can download this BIOGEME V18.zip. Meanwhile that the software is being downloaded, I would like to give you a little bit of background on BIOGEME. BIOGEME is an academic open source software which is developed by Professor Michel Bierler at EPFL Switzerland. The earlier versions of the software has a graphical user interface. It's a very simple interface, very easy to work. That's why I chose to start with that and teach you BIOGEME with the earlier versions of it. But the more recent versions include some Python programming. If you're familiar and comfortable with programming in Python, maybe it's easier to work with the more recent versions of the BIOGEME on your own after we finish the lecture working with the early versions. There is an interesting paper presented and published back in 2003 by Professor Bierler, which gives you a good introduction on BIOGEME itself. The paper is BIOGEME, a free package for the estimation of discrete choice models. There's also a more recent version of the paper which describes and gives you an introduction to the Python version of the BIOGEME, which if you're interested, have a look and read those papers. It will be beneficial if you're interested to learn more and work more on BIOGEME on your own after we finish the lecture. So the zip file is downloaded. I unzip the zip file and it will give you a folder containing a couple of files. And that's all you need to work with. If I click on WinBIOGEME, I will start seeing the user interface of BIOGEME, which has a box for model a specification file, which I can select a file from it. There's also a part for data file, and you can specify the working directory, and then you can estimate the model by clicking on the estimate button. Now let's go back to the guide to BIOGEME. So we downloaded the files for Mac and Windows as you wish. We unzipped the files in a step 2, and as I showed, we will be using with the file called WinBIOGEME. In step 3, I want you to download the examples and tutorials. So there are 2 links here, one for examples, example v18.zip, and also the tutorial you need to go over, tutorial v18.pdf. So let's go ahead and download these files too. Let's open the downloaded tutorial for BIOGEME 1.8. This is a very self-instructive tutorial, which we will partly cover in this lecture, but if you're really interested to excel your skills in estimating discrete choice models using BIOGEME, I really highly encourage you to continue your study with this tutorial and continue working with BIOGEME, go over some of the more advanced examples that is given in this tutorial, to learn more about how to estimate discrete choice models, maybe beyond what we will cover in this unit. So the tutorial includes multiple sections or chapters. There's an introduction to BIOGEME. In section 3 or chapter 3, it includes a simple example which we will cover. It will also go over some of the description of the parameter file, model specification file, and data file. It also talks about the optimization algorithms included or incorporated in the BIOGEME. And in the later chapters in the tutorial, it will cover some of the more advanced models, which is beyond the lecture. But to get us started, let's go back to the step-by-step guide as I provided. So in step 4, open the tutorial file as we did, go to section 3, a simple example. So let's go to a simple example, page 5. There it is. Let's start with an example. Assume that we want to estimate a multinomial logit model with 6 alternatives, with 6 choices. Imagine these choices could be using a private car, sharing a ride with someone, walking, biking, taking a train, and taking a bus. So in this example, we will have 6 alternatives, where the utility function associated with each alternative, or alternative I, is specified as equation 1, as you can see here, where this is the deterministic portion of the utility, if you remember, which is specified as vi, the utility function of alternative I, equals to a constant associated to that alternative I, which we call alternative specific constant, plus beta 1 xi1 plus beta 2 xi2. xi1 and xi2 are the variables that we want to include in the utility function, and beta 1 and beta 2 are the parameters that we would like to estimate using BIOGEME. So as alternative specific constant, for each alternative we will have one alternative specific constant. Beta 2 and beta 1 are the coefficients to be estimated. In order to estimate the coefficients of this model, we use a data file called sample.dat, which includes multiple variables in it. So now let's go to the folder that we downloaded on the example. So if I unzip the examples folder, and if I go into it, I go to the folder basic examples, and I see a lot of example files, right? But let's open the file that the tutorial was talking about, which is the sample.dat. You need to open this in a text editor. If you double click on it, it may not be open in a text editor. So I'm using a text editor, Sublime Text, which is a commonly used text editor in Mac, but you can open it in any other text editor, not limited to what I'm using here. So if I drag this and open it here, it doesn't look nice. I need to uncheck this word wrap so you can see it like an Excel file. So this is the sample.dat, which actually includes all the input data for estimating a discrete choice model in this example. So each row includes one observation. How many rows do we have? We have 1,000 rows. So we have collected 1,000 observations from multiple people. You see there is a column named choice that represents the choice of the individual that is being recorded here, that what alternative he or she has chosen. So this individual decision maker has selected alternative 5. The second decision maker has selected alternative 3, alternative 2, 2, 3, 4, 4, and so on. There are also a couple of other variables listed here, which are specified as x11, x21, x31, and so forth and so on till x621. We also have some variables called AV1, AV2 till AV6. So let's go back to the tutorial and continue reading this. So we open the file sample.dat, which includes the following data: choice, taking the value from 1 to 6, identifying the choice actually made for each observation. The variables x1, x21, x31 till x62, which are the two variables of the model associated with each alternative. These are the attributes of interest. They could be travel time or travel cost, for example, but they're not limited to that. They could be anything. But let's imagine there are travel time and travel cost in this example. So we will have xi1 is travel time, and xi2, let's say it's travel cost, for example. So for each alternative, we will have a travel time, right? We will have a travel time for a private car. We will have a travel time for if you want to share a ride with someone, a travel time for bus, for train, for bicycle, for walking. Same thing with travel cost. You will have a travel cost associated with each alternative. That's why we will have 6 x1s and 6 x2, right? So x11 represents the travel time of alternative 1. Next, we will have some variables as we saw in the sample.dat file as AV1, AV2 till AV6. These are if they take the value 1, it means the alternative is available. If it is 0, it means the alternative is not available. I think I briefly touched on in last lecture that when you want to estimate a discrete choice model, let's say a mode choice model, in the context of travel demand modeling, it is very important to know what alternatives are available to decision makers. For example, if I live in CBD area, I have pretty much every alternative available to me, from walking, bicycle, taking a bus, taking a train, private car, etc. While if I live in a very far suburb from CBD, I may not have access to a train station or a bus service. So it is very important to find a way, like including these variables AV1, AV2, to represent, to show whether any of those 6 alternatives are actually available to the individual or decision maker. So as we saw in the sample.dat, BIOGEME assumes that the data file contains in the first line is a list of the labels corresponding to the available data. So if I go back to this, so the first line includes some of the information related to what these numbers are, and each subsequent line contains the exact same number of numerical data, and each row corresponds to an observations. BIOGEME also needs a file where the model specification is described, Again, you can use your favorite text editor, but the model specification file is a file with .mode at the end. So if I go back to my example folder, I'm going to see a bunch of files with .mode at the end, right? So let me open one of them. Let me see if I can find the more easier one, which is this multinomial logit model basic.mode. That's how it looks like. We will specify the utility functions and other related information about the utility functions in this file. So sample.dat is is equivalent to the survey data that you collect, and this specification file, which is .mode, is your properties of the utility function. Going back to the tutorial, so for this simple example, in the model specification file, we have at least 5 sections. The first section is called choice. So if I go back to this file, this is the first section that we will work with. Here you actually specify the name of the column that is associated to the selected alternative in the input data. So look, this is choice. This is linking the specification of the model to this column, telling the software that if you want to see what alternative is selected by each individual, you need to look at the column named choice. So if I change this choice to ABC, what I need to do in the .mod file is change this to ABC as well, so the software can know which column actually is linked to the selected alternative. Let me put this back to choice, and this one's also choice. So step back a little bit. The first line, if you put 2 dashes here, the software doesn't read the line. The other section is the model description, as it says. You can write whatever you want to write here. You can describe the model that you're specifying. You can write your name as the model developer, and whatever information that you want to read next time that you want to have a look at this file, or if you want to give it to someone else so they know what they're looking at. So we covered this choice section, which is very important. The next section is specifying the variables in the utility function. In a very basic utility function, we may want to only have alternative specific constants and maybe not include any other variable like travel time or travel costs. So that's what you see here. We have 6 alternative specific constants specified, which has an initial value, which the software is going to estimate these, but you can help the software to give it some initial value. You can leave it as 0. You can also specify some lower bound and upper bound. So when the software actually tries to find the estimated value for each variable, specifying this lower bound and upper bound help the software to search in a range of numbers so it can give you the answer more quickly. There is something called a status, being 0, variable being 1 means fixed, which is very important. I don't think if we covered this in the previous lecture, but when you estimate a discrete choice model, you always need to select one of the alternatives as a reference alternative. And this is mainly for numerical calculation purposes rather than having any impact on the interpretation of the model. We need to be able to use that utility maximization framework and the likelihood maximization numerical framework. We need to specify one alternative as a reference. It doesn't really matter which alternative you specify as a reference, although the actual numbers that you get at the end for your estimated utility function will be different, but when you calculate the probabilities using those utility functions, the probabilities will not be affected by the choice of the reference alternative. So in this case, I would recommend just choosing the first alternative specific constant as a reference. So we change this to 1. We fix this, but the rest of the alternative specific constant, and if we want to add other variables, we leave them as variables. So let's go back to the tutorial. So we covered the first part, which is the choice. Note that in that choice section, the syntax is case sensitive. So if you write it with the small letters, is different with writing with capital letters or the first letter being capital. In the second part, which is called beta, as we went over, the section describes to BIOGEME the list of coefficients that must be estimated, as I talked about. The next section that I would like to introduce is the section on utilities, where you actually specify the utility function. The specification for one alternative must start at a new row and may actually span several rows. For each of them, 4 entries are specified. You need to specify the identifier of the alternative with a numbering convention consistent with the section choice. You need to specify the name of the alternative. You need to specify the availability condition, whether the alternative is available or not, and also the linear in parameter utility function, as we see here. So let's go back to the file here. So in the utility section, I have my 6 alternatives listed. I have the name of the alternatives. I have the variable associated to or corresponding to the availability of the alternative, and also the actual form of the utility function. So in this case, you can see that the utility function is specified only as 1 multiplied by the alternative specific constant. So in fact, the utility function would be vi equal to alternative specific I. It doesn't have any other variable. Since we have specified this term 1 here, which is an expression, we need to define what is 1 actually, because the software can't really automatically detect if you type 1 in English. It can't really relate it to the numeric value of 1. Either we could replace these ones by 1 here, or we could write 1 as it is done here, and in the next section, which is the expressions section, we can define the arithmetic expressions for the name that are not directly available from the data. So here we say 1 equal to 1, so the software automatically replaces all the English ones here with the numerical value of 1. As I said, alternatively, you don't need to do that. You can just replace this by 1, but I just wanted to show you that this is also possible. And in the last section, we specify what type of model do we want to estimate. So currently, only multinomial logit and nested logit and cross-nested logit, and also the network GEV model, which we haven't yet covered in this lecture and we won't cover, can be done in this version of the BIOGEME. So to specify multinomial logit model, you need to write this syntax, which is the $value MNL, which tells the software to estimate a multinomial logit model. Let's go back to the tutorial. So you can see in the utilities function what we did in the specification file was specifying the utility functions. But in the example I showed you, we only covered the utility function only includes the alternative specific constant. You can add more variables to it, just like the example we had here. If I go back a few more pages, look at this utility function. This utility function has vi equal to the alternative specific constant I, beta 1 xi1 plus beta 2 xi2. So if we want to specify this utility function in the specification file, we can do it as it is shown here. where the alternative is specific constant 1 multiplied by 1 plus beta 1 multiply x11 plus beta 2 multiply x12. We need to repeat this for every alternative. So alternative specific constant 2, 3, and 4. Since x1 and x2 in this example is assumed to be a generic variable, if you remember from the previous lectures, like travel time and travel cost are generic variables, they apply to any alternative. We only estimate one beta for all the alternatives. So the betas are, so beta 1 is not alternative specific, it's a generic coefficient. So beta 1 remains the same for all the alternatives, while we have x11, x21, x31 associated to, for example, travel time of alternative 1, travel time of alternative 2, travel time of alternative 3, and so on. Same story with beta 2 and x12. Please note that this x11 and x21 are the actual column name in the input data. So if I go back to my sample.dat file, you can see that these column names are also x11, x21. So remember, this was, for example, travel time of alternative 1, travel time of alternative 2, and this is, for example, travel cost of alternative 1 and alternative 2. So if I change this to something like, let's say, ABC11, what I need to do is when I want to specify my model, when I want to specify the utility function in the specification file, I need to, instead of putting x11, I need to put this as ABC11. So whatever variable you have here, it must have the same name as you see on the column name here. Okay. We went over the expressions. This is how to compute attributes that are not directly available from the data, and also the section model that gives you the capability to specify what type of model you want the software to estimate for you. Now let's go back to the guide to BIOGEME. So we went up to step 4. We covered a little bit of the tutorial file. You are now familiar with the input files for BIOGEME. For example, the sample.dat, which is the input data, and also whatever .mod, which is the model specification. Now open WinBIOGEME, the graphical user interface of BIOGEME, and we can specify the model specification and the input data, and let's estimate our very first multinomial logit model given the example files that is already there. Okay, let's go to the folder that we had the BIOGEME files in it. I'm gonna run this WinBIOGEME. And in the first box, I need to give the model specification file address. So if I click on select the file, it's the kind of older version of giving file or browsing files. So it's a little bit hard to do that without knowing the actual address of the file. So if I go to my basic examples file, I'm going to give the model specification file. So let me just get the address here so I don't have to type or find it somewhere. I'm going to copy this address file and go back to here, select the file. I'm going to paste the address here. There it is. So I'll go to basic examples and I'm going to select the mnl basic.mod. You can see the file actually here, a snapshot of the file here. As my model specification, I am also going to give the software the address for the data file. I'm going to give it the sample.dat file and OK. And here is the working directory. So all the output files will be saved in the basic examples folder. So now you need to simply click on estimate, and congratulations, your first multinomial logit model is estimated. Let's see what files this software will give us. The most important file is this file which ends with .rep. So you can actually click on display file, and this is the outcome of the estimation. So this file has automatically been generated. It has the name of the Professor BIOGEME. It's an example of a model specification file, and it gives you some of the parameters and information about the estimation process. So the model is multinomial logit. This is what we specified in the specification file, the .mod file. We had 5 parameters to estimate. Why 5 parameters, if you remember? We had 6 alternative specific constant. We made one of them as fixed, being the reference alternative. So there's 5 other alternative specific constant remains to be estimated. We had 1,000 observations from the sample.dat file. The software calculates different log likelihood values. The initial log likelihood value is minus 1,605, and then when the estimation finishes, using that log likelihood maximization framework that we covered in the last lecture, the log likelihood actually increases to minus 1,588. So the log likelihood has actually increased a little bit. It's a negative value, so when the number actually decreases, it means that the value is increasing. And it required 4 iterations to reach convergence. But then now let's actually look at the utility parameters. So we had alternative specific 1, alternative specific 2, and so on and so forth. And these are the estimated values as you see here. So the first alternative specific constant is assumed to be the reference and is fixed, but the software has estimated different values for every alternative specific constant, as you can see here. So minus 0.03, minus 0.08, minus 0.11, minus 0.19, and so on. And it also gives you the expression of the utility functions and also some more information, again, which is beyond today's lecture on correlation of the coefficients and so on and so forth. But these values are the most important parts that you want to get from this multinomial logit estimation practice. Now let's go back to the guide. So we estimated our first multinomial logit model, and we looked at the outcome of the softwares by clicking on the display file. You can also find the same file in the working directory if you're interested, and a few other files which we don't review at the moment. And in the last step, now that you know how BIOGEME works, you know the basics, you know the input files, you know the output files, you need to go to section 23 of the tutorial covering basic examples, page 75 of the PDF, and let's go over some more examples to have a better understanding of how BIOGEME works and how we can actually estimate a discrete choice model using this software.